In this lesson, we will discuss parallel RLC circuits in parallel. When analyzing the circuit shown, the following branch currents can be determined. The current through the resistor is equal to the voltage source divided by R. The current through the inductor is equal to the voltage source divided by the inductive reactance, X sub L. And the current through the capacitor is equal to the voltage source divided by the capacitive reactance, X sub C. I sub S is equal to the square root of I sub R squared plus the quantity I sub L minus I sub C squared, or I sub S is equal to the square root of I sub R squared plus the quantity I sub C minus I sub L squared. For case 1, if X sub L is greater than X sub C, then I sub L is less than I sub C. For case 2, if X sub C is greater than X sub L, then I sub L is greater than I sub C. For case 1, where I sub L is greater than I sub C, the phasor diagram is as shown. For case 2, where I sub C is less than I sub L, the phasor diagram is as shown. Let's now look at an example. In the parallel RLC circuit shown at the lesson beginning, R is equal to 250 ohms, X sub L is equal to 350 ohms, and X sub C is equal to 1500 ohms. Find I sub S where V sub S is equal to 64 volts. The current through the inductor, I sub L, is equal to V sub S divided by X sub L, or 0.18 amps. The current through the capacitor, I sub C, is equal to V sub S divided by X sub C, or 0.04 amps. I sub L minus I sub C is equal to 0.14 amps, and I sub R is equal to V sub S divided by R, or 0.26 amps. Therefore, the total current I sub S is equal to the square root of I sub R squared plus the quantity I sub L minus I sub C squared, or 0.30 amps.